Alright guys, here is one video to help you out when you are graphing rational functions. I am going to apologize in advance. There's probably going to be a lot of scrolling and a lot of jumping around on the screen. You guys know how it works when we're in class. We got to do a bunch of different steps. We got to scroll to see what we need. So just roll with it, and hopefully this will help you out. So we are going to start with f of x equals the quantity x squared minus 7x plus 12 divided by the quantity 2x squared minus 6x. And we're going to start it just like we would do in class. We've got 5 or 6 steps that we're looking at when we're graphing these, and then we sketch the graph. Again, remember, we're not looking for like crazy detailed graphs. We're just looking for a certain number of things and a certain set number of points, and then we can just kind of sketch it after we've looked at our graphing calculator. So our first step is our y-intercept. Remember, we get our y-intercept by plugging a 0 in for our x squared. So I'm going to have a 0 squared minus a 7 times a 0 plus a 12 all over a 2 times 0 squared minus 6 times a 0. So I can show you that, yeah, that numerator is going to be a 12, but the denominator is going to be a 0. So what ends up happening is 12 divided by 0, it's undefined. So ultimately, there is no y-intercept. Okay? No y-intercept. Our graph is never going to cross the y-axis, so we don't have to worry about actually plotting that point. Second step that we did, we talked about, are there any holes in the graph? And remember, we find holes in the graph by saying, okay, what cancels? What in our numerator cancels with what in our denominator? We can't know that until we actually factor our numerator and our denominator. So the numerator, I'm going to look for two numbers that when I multiply them, I get a positive 12, and when I add them, I get a negative 7. That's just simple factoring right there. So that will factor into an x minus 3 and an x minus 4. My denominator is not a trinomial, so I'm not going to factor it like I did the top. What I'm going to do is look for a GCF. The GCF of those two terms, 2x squared and 6x, that is a 2x. So I'm going to factor 2x out, and then in parentheses I will have an x minus 3. And if you notice, the x minus 3's are going to cancel. I totally picked a different color. There we go. X minus 3's are going to cancel. So that's what ends up canceling. So we cancel, there we go, the x minus 3's. So we have a hole in the graph. Okay. In the graph, there we go. I can speak so much faster than I can write. We have a hole in the graph at x equals 3. Now remember, we can't really take care of that hole in the graph until the very end, but that hole in the graph does kind of, it's again reigning supreme over everything else that we have. All right, so now the next step that we went to zeros. We take our numerator, we set it equal to 0 to solve for our zeros. Now, I know that we went and we canceled this, but remember, I'm going to oh, I don't know if that's going to work. Let's see if that works. I don't want to waste too much time. Oh, yeah, there we go. We'll take that one out of there. We're going to get that out of there. Yep, just, bear with me until oh, that's going to not work. All right. That's fine. We'll leave that there. Sorry, guys. It's been a long day. Can you tell? So number 3, zeros. So we take our numerator, set it equal to 0. We've already factored it. That was factored into an x minus 3 times an x minus 4. We set that equal to 0. And of course, we get zeros at x equals 3 and x equals 4. But remember, we have that hole at the graph at x equals 3. Oh, got to pick the right pen. What pen did I use in class? Oh, I use this one. So even though we found it, we crossed it off. That's not something that we're ever going to graph because, again, we have a hole at the graph at x equals 3. The next round, step number 4. Let's go with the green. Step number 4, vertical asymptotes, right? Vertical asymptotes. Remember, we find that by setting our denominator equal to 0. So I have a 2x times an x minus 3. I set that equal to 0. And of course, I can use the factored form. That's not a problem at all. So I set my 2x equal to 0. I set my x minus 3 equal to 0. So I should have vertical asymptotes at x equals 0 and at x equals 3. But remember, we got a hole in the graph at x equals 3. So that one's not going to work. So I'm just going to have that one asymptote. And then last but not least, we will rock the orange while we talk about horizontal asymptotes. Okay, so horizontal asymptotes. I know there's so much downtime. I feel like I should be talking to you guys as I'm writing this. Hi, how's it going? Hope you had a nice day. Can't wait to see you tomorrow. All right, so horizontal asymptotes. We got to look at the degree of our numerator and the degree of our denominator. So scrolling back up, I told you there would be a lot of scrolling. Sorry about that. So the degree of our numerator is a 2. The degree of our denominator is a 2. So according to our half sheet cheat sheet, which you are not allowed to use on the quiz, right, when the degree of the numerator equals the degree of the denominator, our horizontal asymptote, is at y equals, and what we do is we take the leading coefficients. The leading coefficients, scrolling, so sorry. The leading coefficients here are 1 and this 2 right here. So my leading coefficients are 1/2. So I have a horizontal asymptote at 1/2. Okay. Now I know today in class we talked about the slant asymptote, but remember you only have a slant asymptote when A, you don't have a horizontal asymptote, and B, the degree of the numerator is 1 greater than the degree of the denominator. So we are actually set. All we need to do now is sketch our graph. We found all of our information. Heading up to the graph, and I'll go backwards. My horizontal asymptote was at y equals 1/2. So sketching the graph there, right? The asymptotes are always just dashed lines, dotted lines. We had a vertical asymptote at x equals 0. We had a vertical asymptote at x equals 0. I think I used green for that. So we graph. I know it's hard to see because it's actually on the axis, but that's here. I'll drop it down a little bit for you. So there's our horizontal asymptote. We had the other one that x equals 3, but nope. There's a hole at the graph, so we can't do that. Zeros, we've got them at, according to this, it says x equals 3 and 4, except we're not going to graph the one at 3. All right, so we should have one at 4. So I'm going to go over 1, 2, 3, 4. There's a 0. Okay, the hole in the graph will come back to, and I do not have any y-intercepts. So I've graphed everything that I have here, my 5 steps. Now I'm going to go to my graphing calculator.
Mrs. Sengel, please call 5300. Mrs. Sengel, please call 5300. Thanks.
Sorry for the pause. Mrs. Carver came on and made an announcement. So you're going to go to your graphing calculator. You're going to do that. No, I'm not going to show you how to do it. It's now, the second year using these things, you guys should know that you're going to the y equals. So you go and you get your graph, and all you're going to do then is sketch. Remember, I don't need crazy detail when it comes to the points. So when I'm sketching, you'll notice that your graph comes up here like this. It's never crossing that asymptote, right? And then it's also over here like this. So that's fine. The only thing that I have to watch out for, is, remember, we had a hole at x equals 3. So I'm going over to 3 at my x-axis, and I'm going to basically erase. I hope you saw that. I know it was a little bit tough to see. I'm basically going to erase that little section right there and put an open circle. Okay, I'm going to put an open circle there for you to show that there's a hole in the graph. So then take a look at the full screen for it. Pause it there if you need to. And that is how you graph a rational function. Okay.